Thank you for joining this presentation. My name is Andreas Willumsen and I work at EMC Computer Systems. I've given my presentation the title, Big Data, What is it and Why It Does Matter. My presentation will shortly take you through the digital universe, followed by an identification of what classifies data as big data. Secondly, I will attempt to let you understand why big data matters. And lastly, I'll give you a few directional tips on how to get started with your big data strategy. How big is big data? Big data has led to some very positive social and economical changes in our society. Consider, for example, the rapid adoption of GPS-enabled media-rich mobile devices and of social network connecting us all globally. Together, they've enabled a new way of living spontaneously, instantaneously, and in constant exchange of data. These ways of living are generating loosely big data. In a survey by IDC called the Digital Universe, estimations were made as to how big the digital universe would be. And IDC projected that by year 2020, the digital universe will reach 40 zettabytes. And just to let you know how much 40 zettabytes is, it equals 50 times the amount of all the sand grains on all the beaches in the world. So a massive scale. But one of the not-so-secret secrets about big data is that it's fueled by the properties of the cloud. In fact, it's the attributes of the cloud, such as economies of scale, affordability, extensibility, and agility, that enable us to create big data and to tackle its challenges. Simply put, the big data challenges expose all of us to the details and the limitations of the underlying information structure, and it forces users also to move to the next generation of breakthroughs. When this happens, you can solve problems you previously couldn't, and you can take on challenges you previously wouldn't. EMC finds itself positioned today in the intersection of cloud and big data. And because of our unique position, we're often asked the question, how big is big data? It's really an intriguing question whose answer seems to lack consensus. I think a common misconception is that big data refers solely to the size of the data. While size is certainly part of the equation, but there are other aspects and properties associated with size. For example, consider the speed at which data is being generated and the number and variety of sources simultaneously generating data. Let's take a look at each and see what classifies data as big data. I think we can all agree that a 40 megabyte PowerPoint presentation or a 1 terabyte healthcare image or even a 1 petabyte digital movie is big data. But I could argue also that they are not big data simply because of their sizes. What is big today may not be big tomorrow. But I will argue that they are big data. The 40 megabyte PowerPoint presentation is big data when you cannot share it with your colleagues. And the terabyte healthcare image is also big data when the doctor cannot instantly have a look at the data images and make his amendments of what is going on at the picture. And also the petabyte movie is big data when you cannot render edits with the time constraints of the business. So we demystified the number of one misconception at least, which is that data is solely about size. As we see, big data is really also about any attribute, size being one of them, but it challenges the constraints of a system's capability to business needs. Another interesting aspect of big data is also that they are not the same form or same structure perspective. Some big data have its form, it's well defined, like transactions into a database. And some big data may just be a collection of blog entries like Twitter, or that contains images or tables or videos all kept in the same data storage. But this leads us to the final aspect of big data, which is called generation, diversity, and interconnectedness. Big data generation ranges from automated generation of information by applications such as images of weather predictions to manual entries into Twitter. But changes are generated constantly, and the data gets more accurate. Despite of the size, the speed, and the source of the data, big data drives to the need to make some sense out of this chaos. So understanding the interconnectedness and being able to harvest information from the information hidden in big data unlocks big data's value. So it's all about collecting, analyzing, and understanding big data, and this is becoming a differentiation strategy for businesses, but might very well become fact of life tomorrow. Being able to run analysis and find the accurately as possible will lead to more precise action, and in turn also lead to more profits or savings. So why does big data matter? Well, big data matters not only because of the technological challenges it imposes, since these challenges will often also be the intangible effects that will transform the way we work and live. Let me give you an example. One example is the electric car. It's operated 100% on energy from in-car batteries. But how are electric cars related to big data? Well, charging a battery consumes as much energy as a household, so by buying an electric car, a household doubles its energy consumption overnight. And this is also truly impacting the electric grid and the requirements of this grid. So in essence, electric cars forces the electric grid to be extremely well managed. It has to ensure that there's a constant availability when needed, where needed, and at a capacity needed. And this is where big data becomes interesting, because on the one hand, the monitoring of the electric grid provides an understanding of the power collection, the availability, the distribution, and the location of data. But it's all about making it available in real time. So on the other hand, every electric car comes equipped with very sophisticated monitoring and communication systems that is able to provide the data on the location of the car, its performance, consumption, and energy reserves. And together they generate a constant flow of big data in high volumes and from a variety of sources. So it needs to be analyzed and acted upon in real time to prevent blackouts. But wait, I think enabling the electric grid with big data means not only to collect data, it also means to analyze it in near real time, and that is big data. So to summarize, why does big data matter? Well, it matters of three very simple, but it's also very interconnected ways. We have new data, and this is big data being generated today that contains an enormous amount of information and not previously available to us. But secondly, it's also about unlocking value of big data, because the value locked into big data can be unveiled through automated big data analytics, because big data is digital data. And third, the type, depth, and sophistication of the analytics that can be performed today might enable us to make far more predictive analysis and influence how we shape the future. Let me deep dive into these three categories here. New data. We no longer focus on capturing transactional data to better understand clients and try and understand the demand. So today, e-commerce rather focus on what is called clickstream, which is really capturing the path that the consumer takes before making a transaction online or abandoning a cart. But clickstream data also includes some very tangible information, for instance, style, color, opinions. But more importantly, it aims at understanding the human purchase process to tailor future shopping needs or experiences, and of course also to improve purchase productivity. Secondly, big data in itself is not the only reason why big data matters. We need to analyze the data to unveil the value locked inside of big data. Consider, for example, the simple thing of conducting a marketing survey on the ease of a product. Despite my young age of 32, I can still remember when we used to make pre-formatted questionnaires with a value range between 1 and 5. But today, I think smart surveys would also incorporate big data analytics in order to try and understand the what is called sentiment analysis, being able to process data from YouTube or other social networks. So it's about making this whole interconnectedness between things. And also, in the traditional way of business intelligence, analytics performed historical analysis to learn from the past and gain efficiency in the future. But this is where big data becomes interesting, because instead big data analytics performs predictive analytics for answers. Why is this happening and how can we change it? Take Amazon Books, for example. They deployed what is called a graph layout or graph theory to map individuals and their book choices and made recommendations on the graph layout. So in essence, big data matters because it captures not only things but also the individuals' behaviors and thoughts at a very fine level of granularity in near real time. So I think businesses should always be looking for new insights to better service clients and optimize operations. They should control risk and to be more innovative. Otherwise, they will lose their competitive edge, I think. So how do you get started? Well, there are some prerequisites to consider before jumping onto the big data train. And I've tried to give you a few of my directional tips to start your big data strategy. I think what's very important, first of all, is really to map out and prioritize your use cases. You should make sure it's linked to the value-adding lines of businesses internally. But also, I think it's very important also to analyze your capabilities internally. What internal data do you have at hand, and which external data would you like to take use of? Is your data center capable of monitoring big data analytics, or do you have a scalable storage platform or big data analytics tools? And most importantly also, do you have the right people on board? So based on your analysis, you should also consider, of course, how much are you willing to invest. I think entering professionally into the big data arena, you can be at a very costly affair if not done smooth or smartly to begin with. So this was my take. I thank you very much for your attention on this presentation. I hope I managed to give you some input and also being able to classify big data for you. So thanks very much.